Okay guys, so this is the first method of solving systems of equations. We introed systems of equations last lesson, and this is the first method that we're going to use to solve them. Again, it's just solving by graphing. And really this is probably the easiest method for you guys to do right now. Okay, it's not the easiest method to do at the end of this unit, but it's the easiest to do right now. Because all you have to do to solve a system by graphing is remember that a system is two equations kind of built into the same problem. All you have to do is graph both equations on the same number line. So graph both equations on the same graph. And then remember graphically what the solution to a system of equations is. Graphically, it's the intersection of those two lines. So you graph both equations on the same graph and then see where they intersect. Okay, so they're going to intersect at a point, and you would just write down the ordered pair, and that ordered pair of the intersection point is the solution. So really all this is, and all we're going to do today, is we're going to review how to graph lines. So if it's something you're comfortable with already, if you're like, hey, I know how to graph lines, slope-intercept form, standard form, I know how to do that, you can probably skip ahead to the homework. If you want to get a quick review of how to graph lines from the different forms, I'm going to show a couple examples here. So this first example, we have a system of equations. We know it's a system because it's grouped together by that curly bracket. You have two equations, one on top, one on the bottom. I always like to number them, and if you have the chance, I like to do them in different colors. So I'm going to solve each, or I'm going to work with each equation in different colors. So the top equation I'm going to use red, equation 1. 3x plus y equals 9. That is in standard form. Okay. Now you could easily put this into slope-intercept form, but remember, you could also do it in standard form. In standard form, when you're trying to graph a line in standard form, you usually use the x-intercept and the y-intercept. So if you're graphing that first equation and you want to find the x-intercept, you plug in 0 for y. Or again, what I use, I just cover it up. Cover up the y, solve for x. You're left with the equation 3x equals 9. Real quick, solve for x. Okay. So what's left when you divide both sides by 3? You're left with x equals 9 divided by 3. So your x-intercept, 9 divided by 3, is just 3. Okay. And since I can, I'm just going to erase what I did and do the same thing to find the y-intercept. The y-intercept, plug in 0 for x, or since you're in standard form, you could just cover up the x portion. Okay. What's left over? Y equals 9. There's nothing to solve there. That means your y-intercept is 9. Okay. So we could graph that. We could graph those 2 points. Remember, the x-intercept is the point 3, 0. And the y-intercept is the point 0, 9. So we could graph those. Graph the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y-axis. And 3 on the x-axis. Connect the dots. So again, if you're in standard form, you could put it in slope-intercept form, or you could always graph it just finding the x and the y-intercepts. The second equation, the bottom equation, is in slope-intercept form. So for equation 2, put it over here, equation 2 is y equals negative x minus 1. Okay. Well, remember that minus 1, y equals mx plus b, that b value is the y-intercept. So your y-intercept for your second equation is negative 1. Okay. Let's put that on the graph, negative 1, right there. All right, to get the next point, you need to know the slope if you're in slope-intercept form. So the slope is the number in front of x. The number in front of x, well, there's not a number in front of x, but there is a negative sign. And if there's not a number in front of x, it's a 1. So this is 1, negative 1x. So you have a slope of negative 1. So what that means, instead of negative 1, you put negative 1 over 1. What that means is from that y-intercept, we're going to go down 1 over 1, down 1, right 1. So always down because it's negative, and right, we always go. So down because it's negative, and go to the right. Down and to the right, down and to the right, down and to the right. Whoops. I missed the point. All right, there we go. All right, and then you could draw that line. Let's put that one in blue. All right, and draw that line. I missed a couple of those points, but you can kind of see what we're going for here. We're looking for where do these 2 points intersect. And I know my line's not perfect, but we could see that they should intersect right here. Okay. So that intersection point is the solution to this system. So we just have to count out where that intersection point is. From the origin, that intersection point is over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. Okay. So over 5, down 6 gives us a solution to this system. And you remember your solutions are always going to be an ordered pair. So over 5, down 6, that is the solution. So easy as that. Graph both lines, see where they intersect. Let's do another one. The second example. You got 2 equations in a system, and we're going to graph both. The top one is in slope-intercept form. The bottom one is technically in slope-intercept form, but it's one of those special lines. So let's just start with the first one. The first one, slope-intercept form. This is easy. Okay, I'm not going to write all the parts. I'm just going to point to them. -2, the number in front of x is always the slope in slope-intercept form. And then the part at the end, the +3, that is your y-intercept. So our y-intercept, we're going to start with the point. The y-intercept is 3, so we go up 3 on the x-axis, or on the y-axis, and we put a dot. From that dot, to get to the rest of the points, we are going to use the slope. The slope is -2, or if it helps, you can put -2 over 1. So negative slope means we're going to go down and to the right. Positive slopes go up and to the right. So this one's -2, so we're going to go down 2, right 1. Down 2, right 1. And just do that a couple times until you form yourself a line, and then you can connect the dots to that line. So that's the first equation. We still need to graph the second equation. The second equation is just y equals -5. Y equals -5 is one of those special lines. If there's only one variable, that means it's going to be horizontal or vertical. Okay? If it's y only, it's going to be a horizontal line. It's going to be a horizontal line going through the point y equals 5. Or y equals -5 in this case. If it's x only, it's going to be a vertical line. So we really don't have to do any work for this second line. We're just going to go down to -5 on the y-axis. 1, 2, 3, 4, 5. We're going to put a dot, and we're going to have a horizontal line going through that dot. And that's it. That's our line. These are our 2 lines graphed on the same graph. The point of intersection is going to be the solution to that system. Okay, the point of intersection is right here. Just count it out. Over 1, 2, 3, 4. Over 4, down 1, 2, 3, 4, 5. Over 4, down 5. Solution to the system is 4, -5. Okay. Again, easy as that. So if you're good with this, you could probably move on to the homework. I'm going to do a couple more examples. These are the 2 special cases. Remember, your special cases are no solution or infinite solutions. Alright, this first one, equation 1, is in slope-intercept form. So I know the y-intercept is -1. Graph that. From that point, the slope is 1/2. So from that point, I'm going to go up 1 because it's positive and over 2. So up 1 over 2, up 1 over 2, up 1 over 2. Do enough points to draw yourself a line, and then connect your dots. Okay, so that looks about right. Alright, the second equation is in standard form, so we're going to go back to the standard form method, which is to find the x and the y-intercepts. To find the x-intercept, cover up the y term, and solve for x. So just cross that out. Solve that one-step equation, for x, divide by -3, divide by -3, 6 divided by -3, means we have an x-intercept at -2. So you can graph that. Okay. Now again, since I'm on the computer, I could erase these. Again, all we're doing is plugging in 0 for y if we want the x. If we want the y-intercept, we plug in 0 for x to find the y. Or you could just cover up the x portion. So we're left with 6y equals 6, divide both sides by 6. 6 divided by 6 is 1. So we got a y-intercept of 1. You got your two dots, you connect them, and you'll see from these two dots, when we connect them, that these two lines are not going to cross. Okay. These two lines have the same slope. So if you have the same slope, it means you have two parallel lines, and two parallel lines will never cross. Now, since we're looking for the intersection point, if there is no intersection point, as there is with it, parallel lines, that means this system does not have a solution. So the system is no solution. Okay. And you can probably guess what this last example is going to be. Let me draw this graph real quick. The first equation, the top equation, y equals 2/3 x minus 4. That is in slope-intercept form, so those are the easy ones to graph. So we'll graph this one first, starting with the y-intercept of -4. And the slope of 2/3, so from that -4, we are going to go, it's positive 2/3, so we're going to go up 2 over 3, up 2 over 3, and connect those dots. So that is graph 1, that's line 1. Line 2 is in standard form. Okay. So we'll start with the x-intercept. In standard form, cover up the y portion or plug in 0 for y. You're left with 2x equals 12. Solve for x, you get an x-intercept of 6. So you go ahead and graph that 6. Go over 6 on the x-axis, 1, 2, 3, 4, 5, 6. And there's already a dot there. We'll just put it over there. Find the y-intercept. Plug in 0 for x, or cover up the x portion. Again, you could cover up with your finger, cover up with your pencil. Just get rid of it, because if you plug in 0, it would go away anyways. So solve the equation, -3y equals 12. Divide both sides by -3. You need to get a y-intercept of -4. Put that on the graph. Oh, and that's on the other point. So what this means is that these are the exact same lines. When we connect these dots, even though we were connecting different dots, they end up on the same line. So that means these are the exact same line. Even they don't look like the same line because they're different forms. One's in standard form, one's in slope-intercept form. Turns out when we graph them, they ended up being the exact same. So what that means, where do these two graphs intersect? Well, they intersect everywhere because they're the exact same line. So what we say is that this system has infinitely many solutions. Okay. So that's all graphing, that's all solving systems graphically is. Infinitely many, I think I spelled that wrong. It's okay. That's all graphing systems is. You graph two equations on the same line, see where they intersect. Sometimes they intersect everywhere. Sometimes they intersect nowhere. Most of the time, they're going to intersect in one spot. So really, again, all this is just a review of graphing linear equations, which we did for several weeks in the first semester. So this should really all just be a review. You're just doing the same. You're just doing basically two problems in one.